Welcome back to Mr. Hassan's Maths channel. I'm now going to be answering question number 2 from the Mechanics M1 Edexcel GCE June 2014 R paper. Okay, it's like a replacement paper, and this question here is about vectors, and I'm going to go in through some detail and show a few different ways of dealing with such a question, as one of the students has been asking on the channel lots of questions, and he needs a bit more detail. So I'm answering this question just to give that kind of detail. So it says two forces 4I minus 2j newtons and 2I plus qj newtons act on a particle P of mass 1.5 kilograms. The resultant of these two forces is parallel to the vector 2I plus j. So any vector quantity can be represented by a vector, of course. Okay, so forces, acceleration, velocity, and such, they can be represented as vectors. This is in component form, I and j form. You can also have column vectors, okay, which I prefer to use in my calculation. So what I'm going to do is I'm going to say, let's call the first force F1, and I'm going to write it as a column vector. So you can put the top row is for the I component and the bottom row is for the j component. So that's 4 minus 2. Okay, that's F1. All right, and F2 is the vector 2I plus qj. So it's 2 and q. We don't know what that is. We're going to find out in the question. That's what it's telling us to do in the first part of the question. Find the value of q. So that's F1 and F2. Those are the two forces acting upon the particle P of mass 1.5 kilograms. Now, what we have to do is find first the resultant of these two forces, and we know the resultant is parallel to this vector 2I plus j. Alright, so the resultant of two forces can be found by adding them together. Simple as that. When you got them in vector form, because they're already in horizontal and vertical components, because the fact they're in I and j form like this, you can just add them together. So the resultant of the two forces is when you just add them together. Simple as that. So you take F1, which is 4 minus 2, and you add to it F2, which is 2q, and this gives you the resultant, which is 4 plus 2, which is 6, and minus 2 plus q, which is minus 2 plus q, or if you want q minus 2, makes it look a bit neater. So that's the resultant force of these two vectors. Now, we know that this force is parallel to the vector 2I plus j. It's parallel to this vector. Okay, so there's different ways of dealing with this problem when you're told that two vectors are parallel. What does it mean when they're parallel? What it means is that they're going in the same direction in terms of they have the same gradient. Okay, so they could be going in the same direction. They're parallel to each other. They're going in the same direction. They have the same gradient. That's what it means when they're parallel. Or it could mean that they are going in the same direction in the sense that they are parallel to each other. They could be going in opposite directions, but along that same parallel line. Okay, this line is parallel to that line. Okay, it's just that this vector happens to be going in this direction, and that's going in that direction. They're in opposite directions, but they are parallel. Okay, as opposed to, for example, them being at an angle to each other. Like this vector is not parallel to any of these vectors. Okay, it doesn't matter whether you're going this way or whether you're going that way. It's not parallel to any of these. These three vectors are parallel to each other. Okay, they're parallel to each other. They have the same gradient. One could be going in one direction, the other in the opposite direction, but along a line which has the same gradient as the other line. That's what it means when we say that they have the same direction, okay, and that they are parallel. Okay, they have the same gradient basically. Okay, so that's what that means. In this case, it says they are parallel to this vector 2I plus j. Okay, so now what we can do is, how do we deal with the fact that they're parallel? Well, this is how we deal with the fact that they're parallel. We basically can do it in different ways. One of the ways we can do it, I'll just show you a few different ways. If they're parallel to each other, two vectors which are parallel to each other, they can be expressed as multiples of each other. Okay, that means, like for example, this is a vector and it's parallel to that vector. This could be twice. If this is a vector A, then this would be, for example, 2A. It's twice as big. So the two vectors can be expressed as multiples of each other only and only if they are parallel. Okay, this vector is not parallel to any of these two. I can't express this as something times A. Okay, it might be something times A plus a different vector, but it's not parallel. So even if they're going in opposite directions, this would be minus 2A, for example, if it was like that. Okay, they can be expressed in terms of some multiple of each other if they are parallel. So for sure, if I know that these two vectors are parallel, then I can say that 6 and q minus 2 is going to be equal to some multiple of 2, 1. 2i plus j. Okay, and from this I can derive two equations. One equation I can derive as 6 equals 2k, and the other is q minus 2 equals 1k. Okay, so then I can easily solve this because I can find what k is. K is equal to 3. And if k is equal to 3, that means q minus 2 is equal to 3. So q is equal to 3 plus 2, which is 5, not yq. Okay, that's one way of doing it. So q is equal to 5. So we found the value of q in one way. Now, based upon this, there's another way we can deal with this. Is a lot of students, they say, okay, they're parallel to each other, but what you should not do is you should not write this. You should not say 6q minus 2 equals 2, 1. That's a wrong statement. They're not equal to each other. Okay, obviously you can see they're not equal to each other because 6 and 2 are not the same. So they're equal to some constant times. One of this is equal to a constant times the other. But what you can say is that the gradients, they share the same gradients. The gradients are equal. Okay, because they are in the same direction, the gradients are equal. Because they're parallel, the gradients are the same. So the gradient of this vector would be the rise over the run. And remember, this is like the run, this is like the rise. So you can say that the gradient of this, which is q minus 2 over 6, will give me the same ratio as the gradient of this, which would be k over 2k, basically. If you think about it, this is k over 2k, which is the same as 1 over 2. The k's will cancel, that's all. Okay, so the gradient of this will equal the gradient of that. You can even say 6 over q minus 2 equals 2 over 1 because they're just reciprocals. And from there you can work out what q is as well. So q minus 2 is equal to 6 times a half, which is 3. So you see q is equal to 5. So these are two ways of dealing with the problem. Okay, but don't write that this is equal to that. Write that this is equal to some constant times that. And what you're doing is you're saying this divided by this is the same as this divided by this, and it's like k over 2k, the k's cancel out. Okay, and then you can continue. All right, so it's basically the same kind of thing that we're doing, but it's just a different way of dealing with it. It's like, you can think of it as almost like you're cross multiplying. Okay, it's like you're almost cross multiplying. All right, so that's one way of doing it. Okay, so there we have, if we did it the other way, like if I said q minus 2 over 6 equals 1 over 2, this is like k over 2k, the k's cancel. This will give you the same answer, of course. You'll have, or even if you do it this way, sorry, what I meant to say is if you do it the other way, like 6 over q minus 2, it's perfectly fine for you to say 6 over q minus 2 is equal to 2k over 1k, which is 2 over 1. So we can say 6 is equal to 2q minus 4, and then you can say 10 is equal to 2q, so q equals 5. So of course you get the same answer. So it doesn't matter. This is one method of doing it, using making equal to k, and this is another way of doing it, saying that the gradients are equal. So the ratio of these two numbers and these two numbers will be the same because the gradients are equal. Because this is like rise over run, you see? So they're both perfectly fine methods of finding the value of q in this case. All right, and the same method would work even if k was if they were basically in opposite directions. They were parallel but in opposite directions. They're still going to be equal to some constant times each other. But it's just that constant will end up with them having opposite signs. So this k would end up being something which causes this to be a negative number. Okay, so they have to be. This will end up as minus 6, and this will end up as the opposite sign of this. Okay, so basically, but you still can use exactly the same method when you're dealing with it. You'll give you the same answer basically. All right. So if they tell you that they are parallel, this method would work in any case. Okay, and this method will also work. You'll get the right answer by making them equal to multiples of each other. Because if they're parallel, whether they're going in the same direction or opposite directions, they will give you the same. This method will give you the right answer. All right, so this method and this method, both of them are basically the same. This is one just where you say, okay, that you could equate the I components to each other and you equate the J components to each other. These are the I components here. These are the J components. And here you're saying that the gradients are the same. That means the ratio of the rise over run is equal to the ratio of the rise over the run. And here, when you find the ratio of that constant, that common factor here cancels out. So this is like k over 2k. The k's cancel out, and you're left with finding the value of q. So this is probably maybe a simpler way of dealing with it, but this gives you the understanding of where it actually comes from. Okay, so they both have the same kind of foundation. Starting point is just how you deal with it after. This is by equating the I components and equating the j components and then solving. And this is by, once you've got to this stage, saying that the ratio of the gradients of this, I mean basically the gradients are the same, so the ratio of the components will give you the same answer. Okay, so that's how we deal with this question number 2a. And one more thing I'd like to just mention, because it was something else that was asked. So this is basically 2 and 5. Okay, q is equal to 5. So you got f1 and f2. So 4 minus 2 and 2, 5. So f1 is 4 minus 2, and f2 is, was it 2 and 5? 2 and 5. Okay, so I'm just going through this. This is not part of the question. I'm just going through this just to answer another one of the queries. So as I mentioned to the student in one of his questions, that basically when you want to add two vectors together using a diagram, then you can do that by drawing each vector. So you draw one vector. So let's draw f1 first. You have 4 and minus 2. So I'm making a sketch of that. And then you're going to have 2 and plus 5. So 2 and let's say plus 5. You're going to go up like this. Okay, so let's say this is f1 and this is f2. Okay, it looks like a right angle. Don't think it should be one. Anyway, so just move them along a bit. Okay, so that's f1 plus f2, and that gives you the resultant force. So the resultant force is what you get when you join the beginning of where you started to the end of where you finished. This is the resultant force. So if you draw this vector, which is 4 minus 2, and this vector, which is 2, 5, if you draw one of them, and then where that one ends, you draw the other one, you will get the resultant vector, which is 6, 3. That's the resultant vector here, 6, 3. Okay, and that's, you know, what we would get here. If we put 5 here, you get 6, 3. That's the resultant vector, 6, 3. So the resultant vector is 6, 3. They didn't ask us to find it in part A, but that's the resultant vector, 6, 3. Okay, and we can see that that is parallel to the vector 2, 1. 6, 3 is basically equal to, if you've got 2, 1, it's actually 3 times 2, 1. So it's basically, it's parallel to the vector that they told us is parallel to, of course. Okay, so they're both parallel to each other, as we can see. So that's just a little side point, which wasn't part of the question, just to illustrate the fact. And I could even draw the first vector, f2 first, and then draw f1, and I'll still get the same resultant vector. If I drew 2, 5 first, okay, if I drew 2, 5 first, say this is 2, 5, whoops, let me make a solid line. If I drew 2, 5 first, and then I drew 4 minus 2, okay, so 2, 5 is going to be like a bit more steeper than that. And then I do 4 minus 2, so 4 minus 2, I should get exactly the same resultant vector. Okay, exactly the same resultant vector, okay, which you can see kind of just from this diagram. So this is the vector f2 first, and then I drew the vector f1 after it. When I add them together, I'll get exactly the same resultant vector. Okay, because of course this is 4 minus, this is 2, 5, and this is 4 minus 2. That gives you 6 and 3, of course, same vector. Okay, that's the resultant vector here. Okay, so it doesn't matter which way you draw them. You draw one of them, where that ends, you draw the other one. When you join the beginning to the end, you get the resultant vector. And then sometimes they ask you to find the direction of this vector as a bearing, or they ask you to find the magnitude of this vector, or whatever. You can go ahead and carry on that. So this is basically just a bit of an elaboration on some points that we were mentioning. So it doesn't matter which one of these methods you use, both of them are perfectly fine. As long as they are, you know that they are parallel, whether they're going in the same direction or they're going in opposite directions, both of these methods will give you the correct answer, because that, as long as they're parallel, they are multiples of each other. As long as they're parallel, the gradients will be equal to each other. Okay, the gradients will be equal to each other. Okay, so that's very important for you to understand. Okay, so that's how you deal with such questions. And now part B, just to complete the question, it says at time t equals 0, p is moving with this velocity. Find the speed of p at time equals 2 seconds. So remember, p has a mass of 1.5 kilograms. Okay, and it has an acceleration of 6.3. Sorry, it has not acceleration, it has a force, resultant force that's pushing it. The resultant force that's pushing it is 6.3. Okay, so we want to find the speed of P after 2 seconds. So to find the speed of P, we need to find its velocity. The speed is the magnitude of its velocity. So it looks like we can use the formula V equals U plus AT here, because we know at time equals 0, when time equals 0, that's the initial velocity. That's when you got U. So this is going to be U, the initial velocity, which is minus 2.4. Minus 2.4 is initial velocity. And V is what we have to find. Okay, it says find, because when we find V, that will be the velocity. We can find the speed, which is the magnitude of the velocity at the end. We know that the time is 2 seconds. What we need is the acceleration. Now we know that F equals ma. And we know that the force, the resultant force is 363. The resultant force is mass times acceleration. We know the mass is 1.5, and we need to find the acceleration. Okay, so we can do that, because 1.5 is like 3 over 2, isn't it? This is 3 over 2 times A. So that means A is equal to 2/3. If you just rearrange that, 2/3 of 6.3. Okay, so 2/3 of 6 is 4, and 2/3 of 3 is 3. It's 2, sorry, not 3, 2. Okay, so it's 4/2 is the acceleration. 4/2. Okay, 2/3 times 6. 3 cancels with the 6. 2 times 2 is 4. 2/3 times 3. 3 cancels, leave you with 2. So that's the acceleration. The acceleration is 4/2. So now we can use our equation V equals U plus AT. So V equals U, which is minus 2.4, plus A, which is 4/2 times T, which is 2. So when you add these together, that will give you your velocity. Okay, that will give you your final velocity at 2 seconds. So you got minus 2 plus 6, which is 4. Sorry, minus 2 plus 8. What am I doing? 2 times 4 is 8. Minus 2 plus 8, and you got 4 plus 4. So you end up with minus 2 plus 8, which is 6. 4 plus 4, which is 8. So that is the velocity. Now they ask us for the speed. The speed is equal to the magnitude of the velocity. Very important. You'll lose marks if you just leave this as your answer. That's not the speed. That's the velocity. The speed is the magnitude of the velocity. Speed is scalar, and velocity is a vector. So we need to find the magnitude of the velocity, which is basically found by using Pythagoras, because this is like 6 across and 8 up. So we have got to find this length here, which is done by Pythagoras, which is 6 squared plus 8 squared, which is equal to 36 plus 64, which is 100. The square root of 100 is 10. So we can say the speed is equal to 10 meters per second. And there's the answer for part B. Okay, very important to write your answer as a scalar, as a magnitude of the velocity. Don't leave your answer. If they said find the velocity, you leave your answer in this form. If they say find the speed, you have to find the magnitude of the velocity vector. Okay, so I hope that was clear, especially part A, how different ways of dealing with when vectors are parallel to each other. Okay, so you can make them equal to, basically in both cases they're equal to a multiple of the same vector. Vectors which are parallel are multiples of the same vector. So you can then equate the I and j components and continue like that, find the value of k that way, and then find what you need. Or you can say that the gradients will be the same. So if you divide the components of I and j, for both of them, they will give you the same answer. So q minus 2 over 6 equals 1 over 2k. Or you can say 6 over q minus 2 equals 2k over 1. The k is cancelled, and then you can find what q is. All right, so whichever way you prefer is fine, but it's good for you to understand why we're dividing them here and where that k goes. It just basically is cancelled out when you divide them. Okay, so that's, as I said, 2 ways of doing it. So there we have the answer to this question number 2. I hope that was clear and understandable, and I hope the student who had those questions has a bit more clarification now. Thank you for watching, and if you want to see other questions from this particular paper, you will find some of the questions in this playlist, which should appear over here. So some of these old papers, I haven't gone through all of them yet. If you do have a question from another part of this paper, you can just send me a request and I'll try and get it done as soon as possible. Other questions about vectors you should find in this playlist that should appear somewhere over here. You may subscribe to my channel by clicking on this link, And on the top of the page, you'll find some link to another M1 paper you might be interested in watching. Thank you for watching and see you soon.